with whatever we do. Jioni safu no love with whatever we do. Hale yide munyu skula, nyepamne ne kudlukula. Nyepangi ragala gena, nyepamne ne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Bigi Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kabana wulo kono.
Wulo kono nyita mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Jamani mbere.
Lindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramudu wa kontan.
Ngoto minaka ngala min de fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakilo diata bake karamngoto. Anu sainteng ministry ko di ngole si suko na amanke ko be holiday
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko na karta bulo be damen ala ni je
ngoto
nam
ngoto mon kontan feren
jamani mu ne keda
ifika Lamin ki woko no nyintai mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be soron ne ko fasi ka wulo kono ko
baba
karamol ma ko ni ko karamol soron da amanke kom holiday lem ngoto dindi wo nyanta sila la ala karango la moy yamen kamen fue man kontaan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol soron do kamen courant ma ra do la kombo e ko ndol fanena kara mol soron je kara mol soron Lamin ada lo nyino la amanta ra fena sokon ala mu nekela
Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyina Lamin ya mu na fonye
bi kabin mina kan tambita nteri maning Fatu
ha
tambite la sukol ala dinngol bebe siri be la moyka
Faru dan so am fanan kamira jele ni subala la ngaje dinngol be jet talanta nen kili warol e be serin jelet
sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin
amandara fennela
ite dine ko ni man si yakaru lesino la moy radio to e balon na
mu ne ka ke afonde ba nyara ni alon
telentel jikot
afonde ba mu de be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin manya tala wulo ko adu karam wolbe so da fa ñembe
ko to wole nati bawo ngalle ni Lamin kuntala kombo courant o ka fa me kombo courant asototal wala ki wo kono bari ni ko si su wo kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bongo radio be bulan koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta wo bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
ile subject ro baby jele baby jele
wala nanga coco moy fa dan so wala ngombe tambi kana ngadi ni wolde be ikadum bungo de ko kana
ma asota talde
Lamin mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ko nde ko folle sinila ba ndele sinilo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yin fana bulata ko ko me yen nati jambi Lamin nyanta karana ntel be jiko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wala ka munda kara mo man soro Lamin nyanta kara si so na regular
sila le ayala le sino
dal ko korno ko smolo
kilar ya
be ngala ko momo sa mi do ni ko no kera
mengi bruzo
ndelo ko do la da barro sa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan
yo
nyara nyar wo ko fendi mo la Lamin tayra barro sa
bara te ku folo ajibe nori nya Lamin tamete
teku
bari ko do famo ke
imagine nani nyambol sizol le keje kisigi man sizol no le kafun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko rozor laga
ngalle limbeta de be nyambo do dilanna
nyara ni ko ridin fennat nyara nata
bari famo kada
ngata bungono Tami bungono nyara ngando ko fele ko kete baru nganda ni pelo landi jak
iyo awa la
bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro
Hello viewers and listeners. Welcome to another session of mathematics in the senior secondary school category. Now we move straight to the assignment correction. The assignment we had: a pole and a stick stands vertically on a horizontal level ground. The stick is 25 centimeter long and casts a shadow of 20 centimeter. If the pole casts a shadow of 5 meter, what is the height of the pole? A pole and a stick stands vertically on a level ground. The stick is 25 centimeter long and casts a shadow of 20 centimeter. If the pole casts a shadow of 5 meter, what is the height of the pole? What is the height of the pole? So first we have to get our sketch. Every question of this nature, you have to get a sketch. A pole and a stick stands vertically on a horizontal ground. This is our stick, we assume, stands here. They say the stick casts a shadow of 25 centimeter. The stick is 25 centimeter long. This is 25 centimeter. That is the height of the stick. And it casts a shadow of 20 centimeter. A shadow of 20 centimeter. Let's say this is the shadow of the stick. This is 20 centimeter. 20 centimeter. This shadow of the stick, 20 centimeter. The shadow of the stick, 20 centimeter. If the pole casts a shadow of 5 meters, if the pole casts a shadow of 5 meters, we have some units in centimeters and we have some of them in meters. So we have to convert meters to centimeter or centimeters to meters. So the easiest way to do that, we convert the centimeters, the meters to centimeter. 1 meter is how many centimeter? How many meters? 1 meter will give you how many centimeters? 1 meter is equals to 100 centimeters. 1 meter is equals to 100 centimeters. So 5 meters will give us 500 centimeters. So this 5 meter now will be 500 centimeter. So if the pole casts a shadow of 500 centimeter, this means the pole will be somewhere around here. That is the pole. It casts a shadow of 500 centimeter, like this, to this point. Let's say the length of the pole, the bottom of the pole is T, and so now let's put the top T and the bottom P. The bottom of the pole is P and the top of the pole is T. The stick, the top is A and the bottom is B, and the shadow it casts from the pole to where the shadow ends, let's put that one C. We know this one here is 500 centimeter. The shadow of the pole is 500 centimeter. The shadow of the pole is 500 centimeter. The shadow of the pole is 500 centimeter. That is from C to P on the diagram we interpreted. The shadow of the pole from C to P is our shadow, which is 500 centimeter. Part of it is 20 centimeter. The other part will be 500 minus 20, and that will give us 480 centimeters. Now, what did the question says? What is the height of the pole? What is the height of the pole? This is what is asked, the height of the pole. So we join this to see what is the height of the pole. How do we find the height of the pole? How do we find the height of the pole with this? The height of the pole is TP. The height of the stick is AB, which is 25 centimeter. The shadow of the stick is The shadow of the stick is 20 centimeter and the shadow of the pole is, how do we find the height of the pole? We know this distance from this one to this one is 480, removing 20 centimeter from it. We use similar triangle properties to find the distance of the pole TP. What triangles are similar here? If you look at this, you'll have triangles that are similar. We have two right angle triangle. Right angle triangle TCP. I'll put that here. TCP is a right angle at P, and this is the height of the pole, and this one is 500 centimeter. We have another right angle triangle. A right angle triangle. This right angle triangle ABC is also a right angle triangle. So this distance here is 25 centimeter, and this distance here is 20 centimeters. They are similar triangles. The properties of similar triangles, the ratios of the corresponding sides are equal. This side, and which one is it corresponding to? The ratio of corresponding sides are equal. If you look at AB is corresponding to the side TP, and the side CP is corresponding to the side CB. We have triangle TCP is similar to triangle ABC. So they are corresponding, these ratios of their corresponding side, that is TP all over the side TP all over the side AB is equals to, the other side is the side CP all over the side CB. So we substitute the values. TP is the height of the pole. TP we don't know. All over AB, we know AB is 25, which is equals to CP. CP is the length of the shadow of the pole, that is CP, which is 500 centimeters. 500 all over. CB is the shadow of the stick, that is 20. So we cross multiply. If you cross multiply, you will have 20 TP is equals to 500 times 25. 500 times 25. So what do we do next? We divide both sides by 20 to get TP. We divide here by 20 and divide here by 20 to get TP. 20 will cancel 20. So our TP, the side TP is what? It's going to be 12,500 divided by 20. So our side TP, the side TP is equals to 12,500 divided by 20, that is 625 centimeter. And our question is, what is the height of the pole? Let's look at where is the pole. This is our pole. The pole is TP, and the height of the pole will be the distance TP. So our pole is TP, and the height of the pole will be the distance TP. So therefore, the height of the pole is the side TP, which is equals to 625 centimeter. The height of the pole is equals to 625 centimeter. All right. Let's look at this question now. From the top of a cliff, the angle of depression of a boat on the sea is 60 degrees. From the top of a cliff, the angle of depression of a boat on the sea is 60 degrees. If the top of the cliff is 25 meters above sea level, calculate the horizontal distance from the bottom of the cliff to the boat. Calculate the horizontal distance from the bottom of the cliff to the boat. First, we have to analyze it in a diagram. We get our sketch. We assume this is our cliff. Let's say from the top of the cliff, this is the top of the cliff, T, and the bottom of the cliff, let's say that one is B. Top of the cliff, the angle of depression. Before we get angle of depression, we have our horizontal eye level. This is the horizontal eye level. From the top of a cliff, the angle of depression on a boat. So this is, we assume this is our boat here. This point is where the position of our boat is. So the angle of depression to that point is, the angle of depression to that point is 60 degrees. So this angle here is 60 degrees. The angle here is 60 degrees. If the top of the cliff is 25 meters above sea level, this is the top of the cliff. They say if this is 25 meters above the sea level, meaning the height of the cliff is 25 meters above sea level, calculate the horizontal distance between the cliff, between the bottom of the cliff and the boat. This is the bottom of the cliff, and you have the boat here. What are we asked to calculate? The horizontal distance. The distance, I put where the boat is as C. So what we are asked to calculate is BC. We have the angle of depression 60, and that angle 60 is alternate here to be 60. It will be alternate inside the triangle. We have 60 degrees now. Now we find the distance BC, that is the horizontal distance from the bottom of the cliff to the boat. From the bottom of the cliff to the boat, the horizontal distance is BC. If you look at it, it's a right angle triangle. We can apply the trigonometric ratios. We get the right angle triangle. Let me get out the right angle triangle. This is 60 degrees. Here is 25. This is top, and this B is the bottom of the cliff, and here is the boat, C. So we are asked to find the horizontal distance, and the horizontal distance is BC. What do we use to find this? We use the trig ratios. How do we use them? We look at these sides that are involved. We have our angle 60. Opposite 60 is giving us 25. And the adjacent of 60 is BC. That is what we are asked to find. That is the horizontal distance from the bottom of the cliff to the boat. So we use tan. That involves tan, so we will have tan theta is equals to opposite over adjacent. Tan theta is opposite over adjacent, and our theta here is 60, so we will have tan 60 is equals to opposite is 25 over the adjacent that we don't know is BC. So we cross multiply. If you cross multiply, you will have BC tan 60. BC tan 60 is equals to 25. What are we looking for? BC. So we divide both sides by tan 60 and divide here also by tan 60. Tan 60 will cancel tan 60. So our BC is equal to 25 tan 60 is equal to 25 all over tan 60 is equal to 14.25 over tan 60 will be equal to 14.43, approximately 14.43. What we are asked to find? We are asked to find the horizontal distance from the bottom of the cliff to the boat. This is the horizontal distance from the bottom of the cliff to the boat, and that horizontal distance is BC. So whatever we have, our length for BC will be the horizontal distance. What is our length for BC? Therefore, the horizontal distance from the bottom of the cliff to the boat is BC, which is approximately 14.43 centimeters. So therefore, the horizontal distance is 14.43 centimeters approximately. A woman looking out from the window of a building at a height of 30 meters observes that the angle of depression of the top of a pole was 44 degrees. If the foot of the pole is 25 meters from the foot of the building, on the same horizontal ground, find, correct to the nearest whole, the angle of depression of the foot of the pole from the woman, the height of the flagpole. Let me repeat the question again. A woman looking out from the window of a building at a height of 30 meters observe that the angle of depression of the top of a pole was 44 degrees. If the foot of the pole is 25 meters from the foot of the building, on the same horizontal ground, find, correct to the nearest whole number, the angle of depression of the foot of the pole from the woman, and B, the height of the flagpole. This angle of depression, as I told you before, to be able to solve this properly, you always need a sketch. You have to sketch the information you have. So let's look at the sketch. A woman looking out from the window of a building at a height of 30 meters. So meaning from the foot of the building to the window, the height is 30 meters. From the foot of the building to the window, the height is 30 meters. So we have this as our building vertically. Here is the window of the building where the woman is. I labeled that T. And this is the foot of the building. Let's say that one is B. A woman looking out from the window of a building. Now, angle of depression, before we get the angle, we get our horizontal eye level. This is our horizontal eye level. Now, the woman is looking on a pole. Let's look at the pole again. Observe the angle of depression of the top of a pole was 44 degrees. Of the top of a pole, meaning the woman, where the woman is at the window of the building, is above the top of the flagpole. So we have the pole here, standing on the same horizontal ground with the building. This is the base of the pole. Let's call that one A. And this is the top of the pole. Let's call it R. So the angle of depression from the woman to the top of the pole is 44 degrees. So we have from the woman to the top of the pole, we bring that line from the woman to the top of the pole. This angle here is 44 degrees. The angle there is 44 degrees, the angle of depression. If the pole is 25 meters away from the foot of the building, the distance between the pole and the building is 25 meters. This is the foot of the building and that's the foot of the pole. If it is 25 meters away, this is 25 meters. Then you have, let's look at again. If the pole is 25 meters away from the foot of the building and on the same horizontal ground, find, correct to the nearest whole number, the angle of depression of the foot of the pole from the woman. The angle of depression of the foot of the pole from the woman. So that's the woman to the foot of the pole. The angle of depression is what you are asked to find. You have the woman here to the foot of the pole, this time around, not the top of the pole. So the angle you are asked to find is this angle. The angle of depression from the foot of the pole. The angle of depression from the woman to the foot of the pole. How do we find that angle? This is all we have. Let's see how do we find the angle. We look at the diagram we have. This is a right angle, a horizontal line and a vertical line meeting. Now here also we can have this, a horizontal line here. That's the horizontal eye level at the top of the pole. And this angle, 44 degrees, you can see 44 will be alternate to this angle here. So we are asked to find the angle of depression from the woman to the foot of the pole. We have the pole as we have it. The pole now is AR. I told you before the foot of the pole is A and the top of the pole is R. The building, the base of the building is B and the window where the woman is at the building, that is labeled T. That distance is given in the question. A woman looking out from the window of a building at a height of 30 meters. So we put the height of the building from the base of the building to the window of the building where the woman is looking at, that is 30 meters. So 30 meters is the height of the building from the base to the window. Now we are asked to find the angle of depression from the woman, the angle of depression from the woman to the foot of the pole, or the angle of depression of the foot of the pole from the woman. How do we find that? Before we find that, you just look at these ones here. We have 44 degrees here. Then we have horizontal eye level at the top of the pole. This 44 degrees is alternate to this angle that we have here. That is the horizontal line at the top of the pole. You have 44 degrees alternate angles. Then what else do we have? What else do we have? We are asked to find the angle of depression from the woman to the foot of the pole. Let's look at that. We have right angle triangles in the diagram. We have right angle triangle RT. I've labeled this RT. Let's say C here. Right angle triangle RTC. That is the line, horizontal line from the top of the pole to the building. Horizontal line from the top of the pole towards the building. The point where the two lines intersect is labeled C. That is a right angle triangle. And we have another right angle triangle ATB. The TB is the height of the building from the base to the window, and RA is the height of the flagpole. BC is equal to the height of the flagpole. Now let's find the angle of depression. Let's, as I said, we extract triangles, the right angle triangle. I will extract the triangle ATB, the bigger right angle triangle. This is 25 meters. This is 30 meters. And we are asked to find the angle of depression. If you look at that, that angle of depression will be alternate to this other angle here. The angle of depression is alternate to this angle we have here. So if we find this angle is equals to the angle of depression from the woman to the foot of the pole. So what is that angle? The angle is what we have here. So we label it theta, and this is the angle here. We have it theta. We use trigonometric ratios to find the angle theta. We look which of the three ratios is more suitable to use so that we will have our angle theta. If you look at this right angle triangle, the hypotenuse is not there. So when the hypotenuse is not there, what do? We use tan. So we'll have tan theta is equals to opposite over adjacent. Because we have no hypotenuse, we use tan theta. So our theta is there, and the opposite of theta is the line directly opposite. So we have the opposite of theta is 30, and the adjacent of theta is 25. So we fix that. We'll have tan theta is equals to 30 opposite over the adjacent 25. So tan theta is equals to 30 over 25. So we'll have tan theta is equals to 30 over 25 is 1.2. Find the tan inverse to get the theta. So we'll say theta is equals to tan inverse of 1.2. Theta is equals to, what is tan inverse of 1.2? If you press your calculator, tan inverse of 1.2 is 50.194. Tan inverse of 1.2 is 50.194 degrees. So theta is approximately 50 degrees. What did the question ask us to find? The angle of depression from the woman to the foot of the pole. Let's look at that. The angle of depression from the woman to the foot of the pole. So the angle we have here is the angle of elevation from the foot of the pole to the woman. So which is alternate to the angle of depression from the foot of the pole to the woman, and the question said to the nearest whole number. The angle of depression from the woman to the foot of the pole therefore is 50 degrees to the nearest whole number. So that's what we do. That is the A part of the question. The A is 50 degrees, the angle of depression from the woman to the foot of the pole. So we go to the next one. The B part of the question says we find the height of the flagpole. The height of the flagpole. In the diagram, the height of the flagpole is R. The height of the flagpole is RA. Is the height of our flagpole. How do we find the height of the flagpole? I told you before, BC is equals to RA as the height of the flagpole. What do we need to find? We use right angle triangle. RTC. So in that right angle triangle, we have 44 here as the angle, and this is theta. This line here, that is 25 meter, is equals to the line RC, which is also 25 meters. We have an angle, we have a side, and on a right angle triangle. To find the other side, we use the trigonometric ratio. We have 44 degrees at R. The side we have is adjacent to the 44 degrees, and we are asked to find TC, which is opposite to the 44 degrees. So what do we use to find that? We use tan to find it, because we are looking for the opposite and we have the adjacent. So we will have tan theta is equals to, that's the right angle triangle. Let me get it again. This is 25 meters. This is T, this is C, and here is 44 degrees, and this one is R, the top of the flagpole. This 25 meters, so the opposite is TC. We can have our tan theta as opposite, that's TC. Tan theta is equals to opposite, that is TC, the side TC all over the other side, that is 25. So we find the side TC by cross multiplying. So if we cross multiply, we will have TC the side TC is equals to 25 tan theta. And the theta, if you go to the right angle triangle, our theta is 44. That is the angle in the right angle triangle. So we substitute the 44. So our side TC is equals to 25 tan 44. Our side TC, if you press the calculator, we will have 25 tan 44 is 24.14 meters. The side TC is 24.14 meters. What are we asked to find? We are asked to find the height of the flagpole. What do we have? We have TC. So the whole length of TB is the height from the base of the building to the window. So the height of the flagpole is a part of it. So the top part of that length is 24.14. To get the height of the flagpole, we subtract that from 30 meters. So to get the height of the flagpole, we will have, therefore, the height of the flagpole, is going to be 30 meters minus 24.14 meters. 30 meters minus 24.14 meters will give you what? If you press your calculator, you will have 5.86 meters. 5.86 meters. The question says to the nearest whole number. To the nearest whole number, the height of the flagpole is, to the nearest whole number approximately is 6 meters. So therefore, the height of the flagpole is 6 meters. Let's look at this question. If we come in our next class, we will get this one done. A point H is 20 meters away from the foot of a tower on the same horizontal ground. A point H is 20 meters away from the foot of a tower on the same horizontal ground. From point H, the angle of elevation of the P on the tower and the top T of the tower are 30 degrees and 50 degrees respectively. Of the P on the tower, that is very important, and on the top T of the tower are 30 degrees and 50 degrees respectively. Calculate correct three significant figures: PT, B, A is PT, B, the distance between H and the top of the tower, and C, the position of H if the angle of depression of H from the top of the tower is to be 40 degrees. So with this, we come to the end of this lesson, and until I see you another time. Thank you.
Proof a $500 million emergency fund, which the Ministries of Health and Finance will work on for disbursement and use to fight COVID-19 menace.